Class, what's up? Welcome back. More parallelograms today. What I want you to really take away from this lesson is that this is the complete reverse of 6.2. And if you think about this, we did the exact same thing back in Chapter 3 with parallel lines. We started by saying, if supplementary angles, right? Or not supplementary. Maybe I gave you a picture like this. Alright, and I told you this angle was equal to this angle. Well, we could say something along the lines of if alt int angles congruent, then parallel. Well, then we learned about something like this, where if I change the picture a little bit, and I start by giving you parallel lines, well, now we could say, actually I should finish this, if alternate interior angles, which is what I gave you, are congruent, then parallel, so that's how I can add the green ticks. Well, now I can say, if parallel, then alt int angles congruent. So I was able to mark these angles now as being congruent. So I don't know if you remember that, but it's like you go one way and it works the opposite as well. And what I'm here to tell you today is that it's the same thing with parallelograms, okay? At least for 4 of them. We are going to go over one crazy one right here at the beginning, and we'll get it out of the way early. But again, things that prove that something is a parallelogram, or sorry, I should say, things that we know about parallelograms help us in the reverse fashion too, that we can prove that something is a parallelogram. Alright, so this first one's a little goofy. We didn't really talk about this one, but we know that if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Alright, so this is what the picture looks like here. If you have one set of opposite sides, now again, it has to be the same set that's both parallel and congruent. Keyword here, and. It has to be both. Well, then you can say that the shape is a parallelogram rather than just a quadrilateral. You can be more specific. Alright? Again, please note, that is not this. That is not this. Parallel congruent. It is not this. Do not think this. No, bad. Alright? It has to be one specific set of opposite sides that are both parallel and congruent. Okay? Now we can kind of get into some of our reverse ideas. Alright? We learned that if you have a parallelogram, then both pairs of opposite sides must be congruent. Well, now I can say if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Alright, we can just go backwards. And it looks something like this picture. Alright, moving right along, we start to look at some angles now. Alright, we had if parallelogram, then opposite angles congruent, and now we have if opposite angles are congruent, then Pegram, then parallelogram. Alright. This next one's a little bit goofy. It has to do with having supplementary angles, which I know we learned about in 6.2. But really what we're looking at here, guys, if you can kind of look at this with me, if I draw in this purple part right here, and I look at this angle and this angle, well, 180 minus x plus x is 180. So these angles are supplementary, which means that these are same side interior angles that are supplementary, and we know that that proves that the lines are parallel. Okay, so we could say that BC, the top two lines, BC, and AD are parallel. Well, if we spin the picture, or even just think about it a little bit backwards or sideways, and I now draw this, Well, I can say the exact same thing, which now means that AB and CD are parallel. Alright? And now, if BC and AD are parallel, and AB and CD are parallel, well then what do we have? We have two sets of opposite sides that are parallel. And that's what we're going for here. Alright? So the way or the trick to kind of think about this one is you look at one angle. Alright? So you look at one angle. And then if it is supplementary to both of its consecutive angles. Then the quadrilateral is a parallelogram. Alright, this is a goofy one. You have to think about this. If one angle, right here at A, is supplementary to both of its consecutive angles, well then it's a parallelogram. And it is, right? Because x and 180 minus x make 180. X and 180 minus x make 180. Alright, so that's what you're looking out for on that one. And then, of course, the last one, I shouldn't say the easiest one, but one that if you see diagonals, you should start to get in the hang of seeing this one. Alright, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a Pegram. Alright? So what I want you to understand here, you're just looking at the picture, right? You have to look at what is given, whether it's markings, whether it's angle measures, whether it's side lengths and whatnot. And you have to decide if any of these hold true. Alright? So let's go through a few examples just to kind of get you started, and then we will practice more in class. Alright? So let's see here. Coming up to the top. Maybe? Yeah. Alright. So, let's see if I can focus this again. Sorry about that, guys. Alright, here we go. So, I look at this picture, and it says that I want to figure out if it's a parallelogram or not, and to justify. So if I look at this, I have a 3 and a 3, I have a 6 and a 6. So like if I were to make markings, I could put a tick marks there, tick marks here, and what's the idea here that I want you to take away? Well, isn't this diagonal bisected into 3 and 3? This one into 6 and 6? Yeah, these diagonals bisect each other, guys, and that is one of our ways of proving that something is a parallelogram. And I'm going to say yes, because if diagonals bisect each other, then Pegram. Alright? If the diagonals bisect each other, then it's a parallelogram. Now if I look at number 2, I notice I have a 130, I have a 50, I have a 50. Well, 130 plus 50 is 180. 130 plus 50 is 180. Okay, so this is that situation where we have an angle, and it seems to be supplementary to both of its consecutive angles. So once again, this is a yes, because one angle sup to both consecutive angles. Alright, I'm just going to leave it like that. And you know what? I'm just going to cross this off. I did more than I had to. We don't even need to say that. Cross this off too. Okay, so for this one I'm going to change it. I just want to say because diagonals bisect each other. This one, because one angle is sup to both consecutive angles. Alright, when we look at something like number 3. Well, there's a couple of things here that I could say. 66 and 114 are not equal to each other, and we know that in a parallelogram, opposite angles are supposed to be congruent. So you could go with that, and in fact, I think that's what I'm going to go with. Alright, I'm going to say, so this is a no, because both pairs, if I can spell, both pairs op angles not congruent. And that was one of our rules, right? We knew on the other page that both pairs of angles, my gosh, sorry about that, guys. Both pairs of opposite angles of a quadrilateral must be congruent in order to be a parallelogram. All right? Coming off the long weekend, struggling. Sorry. Okay, moving right along. Number 4. This one's nice and easy, right? We see congruent, congruent. This is a big yes. And we say yes because both pairs op sides congruent. Please be on the lookout and just make sure you understand. I'm looking for words like both. Both. All right? These are important ideas that need to be present in order for us to understand that something is a parallelogram. All right? 5 is that goofy one, hopefully that you recognize from the start. Even though I only have information about one set of opposite sides, I can see that they are both congruent and parallel. So this, again, is a yes, because one pair of opposite sides, both congruent and parallel. And to finish up the video, we look at this last one that we have to do a little bit of work on, all right? Please notice, all right, if I look at these arc marks, the single down here and the single down here, if I think about that, that creates something like this. If I make a Z, all right, so when I have, what is this? What are these called? Oh yeah, alternate interior angles, okay? So I have alternate interior angles that are congruent, which means I have parallel lines, so I can mark this as parallel to this. And what you need to think about, guys, is you need to make another Z, all right, with the other arc marks. So I would do something like this, down here, over here, and again, I have alternate interior angles, so these are also parallel. And now, what would we say? What was like the definition of a parallelogram? Parallelogram is a quadrilateral with two sets of opposite sides parallel. Well, what do we have? Yes, because both pairs op sides parallel. And that is that for this video, okay? We will practice more of this in class, but again, please take away, all we're really doing is the opposite of 6-2. We are now saying that if we see any of these properties happening, well then we have a parallelogram. Alright? Have a great day, and we'll work on this in class.